Hi, my name is Phil and I am a senior lecturer in astrophysics at the University of Lincoln, and I want to use this video to have a look at some extreme seasons on Saturn. And this is mostly due to the rings, which other planets don't have, and it can drive quite extreme and unusual seasons in comparison to what other planets might experience. So, one thing that we kind of know about most of the planets is that the rotation axis is tilted with respect to the orbital plane. So if we're looking edge on at the orbital plane of a planet around the sun, that's kind of the yellow dashed line there. And then the rotation axis is slightly tilted. Now, if it wasn't tilted, it would be kind of perpendicular to that yellow line, but most of the planets have some kind of tilt to it. Now, we know for a fact that the Earth's rotation axis is tilted. It's around about 23.5 degrees, but it does vary, and actually that relates to things like the Milankovitch cycles, which is a whole separate video. But if you think of a spinning top, if you spin it, you'll find that it actually kind of wanders around a bit, and a rotating planet does the same thing. Its tilt can actually vary slightly, but at the moment it's around about 23.5 degrees that Earth's rotation axis is tilted to its orbital plane. Now, we know that basically gives rises to the seasons, essentially, because as it goes around the sun on its orbit, that tilt kind of stays like that, but it goes around like that, which means that the northern hemisphere, southern hemisphere receive more or less light at different parts of the year, which then give us our summer, winter, things like that, because we get more light during the summer, less light during the winter. So it's that tilt that gives us our seasons. If the rotation axis is not tilted to the orbital plane, we would not get seasons. It would be pretty constant. Now, we would if the orbit was elliptical, which meant that it got closer to the sun and further away, which the Earth does do, but it's mostly down to this tilt. So, it gives rise to our seasons. So in this scenario here, the southern hemisphere is basically more tilted towards the sun. That means they're going to have their summer, basically in this particular part here. And then when it's on the opposite side of its orbit, it would experience winter, depending on where you are. Now, if you're in Australia, you're not necessarily going to get the nice snowy scene like that, but you'll receive less sunlight. It will be cooler. Your weather would be different. So it's all down to that tilt, basically. That's for the Earth. We know that for a fact. However, it does occur for other planets as well. So we know for a fact that Mars experiences seasons due to its tilt. And I can't remember the exact tilt of Mars. Should have checked that before the video. But it does have a tilt. And because of that, it goes through seasons. Now, those seasons last longer because it's further away from the sun. So one orbit of Mars is longer than one orbit of Earth. So its summer and winter seasons will last longer. But here's some evidence basically taken by the Hubble Space Telescope of the North Polar Cap. And you can see it basically retreating as it goes kind of from winter into summer. So we know that other planets experience the same thing, and it depends on the actual tilt of the planet. So planets that have a lot of tilt are going to experience a wider fluctuation in their seasons, or a bigger spread in temperature, I should say. Whereas ones that have very little tilt, there won't be much variation in that at all. So let's go back to Saturn. Now, Saturn does experience seasons, like many of the other planets. It has a tilt of about 27 degrees, which is fairly similar to Earth, slightly more, but it has a 27-degree tilt, so it's going to experience seasons in the same manner. As it goes around on its orbit, which is obviously a lot longer than Earth, then the southern and northern hemispheres are going to receive more and less light. You're going to get winter, summer, autumn, spring, and all that because of the change in the amount of sunlight that's reaching that particular hemisphere. And it's about a 29.5-year cycle, so much longer than Earth. Your summer and your winters are going to last much, much longer, but those hemispheres will receive more or less light depending on where it is on its orbit due to that 27-degree tilt. And there will be slightly more extreme is probably not the right word, but there will be a greater fluctuation probably between the hemisphere temperatures because it's a slightly greater tilt than Earth. Now, something that Saturn has that the other planets don't is it has rings. Now, I know you're probably thinking, but Jupiter, Neptune, Uranus, they've got rings as well. You can't see them from Earth, basically. They're quite diffuse, quite thin. They're not significant. But Saturn's rings are quite dense. They're a fairly significant ring system you can see in your back garden with a very small, modest telescope. And these rings will cast a shadow. If Saturn had no tilt, no actual tilt with regards to its rotation, those rings wouldn't cast a shadow. It would be very, very small because the rings are very thin. Whilst they might be hundreds of thousands of kilometers wide, they're actually only meters thick. So if it was perfectly aligned so that it wasn't tilted, there'd be hardly any shadow. But because it has a tilt, those rings block out the sunlight and they will actually cause a shadow on one of the hemispheres of the planet, depending on where it is. Now, that shadow is going to move with the seasons. So as it goes around, obviously the tilt of the ring changes. So on the left-hand side there, the ring is kind of tilted up. It's creating a shadow on the northern hemisphere. But as it goes around to the opposite side, the ring is then lower. So it's going to cast a shadow on the southern hemisphere. So whilst you're getting seasons due to the tilt, you've got this added effect from the shadow where it actually blocks out more light. So on those hemispheres where it would be winter, it's actually going to be like an extreme winter because you're receiving considerably less sunlight than you would if the rings weren't there. So just an example of how those shadows actually move around on the planet. So you can see going from March 2006 to April 2016 that the shadow has basically wandered downwards on the planet. And we remember the cycle is going to be 29.5 years, which is the orbital period of Saturn. So it's going to take quite a long time for it to basically move through. But those shadows move with the seasons. They're related to the alignment of that rotation axis. Now, this is a comparison of the actual temperature on Saturn. So what you've got here is the stratospheric temperatures of Saturn for 2005 and 2008, and then in the middle is the difference between the two. And you can see actually where the rings are creating a bit of a shadow right in the middle. And you're going to find that wherever the rings are casting a shadow, it's going to cause a bigger difference in temperature. So we would expect to see larger variations between the northern and southern hemispheres due to seasons because of the rings, not just because of the tilt. Now, what's that going to do? Well, that's likely going to enhance any seasonal variation, as we mentioned before, because you're blocking out extra light on the winter part, the winter hemisphere, then you're going to get much cooler temperatures for that hemisphere than you would do for the one that's in the summer. Now, that actually can drive or potentially drive massive significant storms as it switches from winter to summer, because you get quite a significant warming during the summer. It goes from being very cold to, well, technically it's still very cold because it's a long way from the sun, but relatively speaking, it will increase more in temperature than, say, the Earth would, relatively speaking. And this is an example of one of these kind of storms that's kind of been caused as it switched into the summer season, really. Now, this particular storm was pretty exciting to watch because it started in the northern hemisphere in the summer season. As you can see, actually got the shadow being cast down on the lower hemisphere. And what happened was it actually went all the way around the planet. So that storm went all the way around the atmosphere of the planet and it actually ended up crashing into itself. So it went all the way around and then it actually joined back onto itself where it originally started. This was a fairly significant storm, which we don't really see in the other planets. We know we've got big storms in Jupiter, the other outer planets, but this one was quite unique, specifically at the time, because it went all the way around and kind of crashed into itself again. Now, something else that happens as well, so we know that the rings block out light because they're quite thick, but they also actually reflect light. So as you can see, the rings are illuminated by the sunlight. Now, on the night side, some of that light reflects off the rings back onto the night side of the planet, which actually can warm it. So again, you've got a cooling effect where the shadows are occurring, and then a warming effect from reflected sunlight that reaches the night side that wouldn't necessarily reach it before. So you've got some very interesting things there that can really mess up the climate and the temperature in the atmosphere of Saturn, which the other planets don't have. Now, as I mentioned before, the other planets do have rings. So you've got Jupiter there on the left, and I believe Neptune, and they do have rings. You can't really see them from Earth very well, because they're really thin and diffuse. You're not going to see them with your own telescope, really. And because of that, they don't really block out any light or reflect any light. So they don't really have any effect on the seasons. So thank you for watching. And if you enjoy the videos, find them helpful, then do consider becoming a member. There's extra videos in the member section as well as other benefits. And it also helps generally support the channel and help me make these videos for you.